Hi, this is Mr. Max with Sankofa Mathematics. So what I'm going to do here today is vectors in two dimensions. This is suitable for learners who are starting off with vectors, understanding it, mostly grade 12 core in Namibia as well. But any grade can actually take heed and also can have a look at this video. Right, so I just have a few notes so that you can understand what the whole vector is about. So in engineering, we want to model quantities that are not adequately described by a single number, for example, like temperature or pressure, but rather a direction and magnitude. These are called vector quantities, and simply we call them vectors. So force is one, it has got magnitude, the strength, and the direction as well. Velocity is another one. It has got magnitude, speed, and direction. So a trajectory when moving along a straight line for some time t. This is what we refer to when we talk about a vector. Sometimes we talk about a scalar quantity, which is just one. Okay, so there is different notation that you need to be able to master whenever we are dealing with vectors. You will see that you will probably see something in most books that the vector is indicated by a bold face letter. It could be an A. Or when you write it, then you can also write with a line underneath, or even at times on top like this. These are all referring to. So the interpretation of a vector is a direction and magnitude. So it is a convenient geometrical representation of a vector. Okay, so we're going to use a lot of grids here, and then you can see exactly the direction and the magnitude of a vector. The length of a line segment, this one normally is also done when you go a little bit deeper. This is the magnitude of the vector. This is sometimes called direct straight line segment. But in core, we are not going to focus on the magnitude. So let me bring in an example here. So if you have a movement or translation, a sliding movement from point A to point B. So you have got this 3 here and a negative 4. The 3 here, right, which represent your direction in the y, it's parallel to the y-axis, which means you talk about going to the right, going to the left. So if this value here is positive, then you are moving in the right direction. If it's negative, you go to the left. The value underneath, it is parallel to the x-axis. That means it's up and down sort of movement. So remember we are talking about the translation, the sliding movement. Okay, so if I bring in here, you can see x movement is across like this, and the y movement is up or down. So when this is negative, it means you have moved downwards. When this is positive, it means then you are moving to the right. Think of it as when you are starting a Cartesian coordinate system. You know that the values of the Cartesian coordinate system for x, you go this direction and it's positive. And when you go up in the y direction, it's actually like a positive as well. So when we go down, when we reverse, when we go down, for example, in the y direction, this is negative. This is typically where you have something like this here. And when you go to the left, obviously the value here will be negative. So here it's positive, so that means it went to the right. All right, let's talk more about a few things so that we can just iron out. The number on top, as I said, is a positive. If it's positive, it goes to the right. If it's negative, it goes to the left. Okay. So if there is a zero, it can be a zero at the x direction or the y direction. It means there is no movement. So if the zero is on top, it means it hasn't moved to the right, nor did it move to the left. If the zero is here under, it means there is no up or down movement. So the vector AB that we are talking about here, you see where the arrow is pointing. So if I start at A, which is called, and I'll bring that up now, okay? When you start at A, and you count 1, 2, 3 units to the right, of course that is positive 3. But now you're going 1, 2, 3, 4 units downwards, and that's how this vector is represented rather on a grid. Right, let me bring in a few exercises here. We are going to write down a few column vectors. So I'm going to bring in a grid. And what we have here are vectors represented. This arrow tells you it's from C to D. And in this particular instance, it's from E to F. And here, for example, the arrow is showing in that direction, which is G to H, and so on. Right, so if I bring them in, CD, if you go here, and now it will be imperative for you to start maybe counting. So when you go from C to D, you'll see that it has to be 1. Maybe I must pick a better color. We're going 1, 2 units to the right, and then 1, 2, 3 units up. So the vector therefore is 2, 3. Please do not write them as fractions. They are not fractions. If we do EF, then you're going down. So first of all, EF, you're going to the left, that is 1, 2, 3, 4. So I expect negative 4, okay? And then you are going down as well, 1, 2. So negative 2 as well. So that is how you find that one. And G to H, you see there is only an X direction of 3, but there is no Y direction. So its vector is 3, 0. And J, K, here you can see you haven't moved to the left or to the right, so the top value should be 0, and only the Y value, that is negative 5, because you're going in a downwards direction. Vectors can also be represented like this. So B, talk about this particular vector here. So 1 to the left, that's negative 1, and obviously 5 upwards. So its vector is negative 1, 5. And C, we talk about this vector that goes in this direction. So you count, it's going to be 5 here and 4 downwards. And lastly, N to M is going to be positive 6 and 1 up. So that's how you can represent them on a diagram, or even read from a diagram and write them down. Let's talk briefly about position vectors. These are vectors that are just starting from the origin, okay? So when we talk about position vectors, they do start from the origin, and they are written like OA, OB, OP, and so on, all right? What you will realize they have in common here is that they all start, as I said, from O. So let me bring in something here. Suppose we have got the points on a Cartesian coordinate system, or the XY plane, and this is a typical point here, the point 5, 6. So if I have my Cartesian coordinate system here, so if I go 5 units to the right and 6 units up, then the point 5, 6, can you see you have got the point 5, 6 here. So this particular point here, it's represented by that movement. So the distance, so if we call this, for example, my point A, okay, then the vector from O, the origin which is here, the vector from O to A, from here all the way, supposed to be a straight line, that vector is then can be written as 5, 6, and so on and so on. So we can also represent vectors, position vectors, from the origin. Okay, so if we were to look for the point negative, let's take negative 5. So negative 5 is somewhere here, and negative 6, suppose it's somewhere here. And when we actually go down, and that point there, and we say that point is the point C, and so its position vector will be from O all the way up to here, and we represent it like this, okay? And that is what we refer to when we talk about position vectors. But when you are doing core level, you are not really going to be asked so many questions with regard two position vectors. But it's always nice to know what is the difference between position vectors and free vectors. So free vectors, they simply do not start from the origin, okay? They are just everywhere, but they can be equal as well. So there is also equal vectors. So whenever you are given a point like the vector OM, and that is 3, -7, you can actually also write that point M on a Cartesian coordinate system as the point 3, -7 in coordinates form. Now, the addition of vectors here, whenever you're adding, if you look at vector A up to C, it's like you're going A, B, it's like a traveling thing, all right, plus B, C. So going from A to C is like you're going from A to B. It's like a journey that you are taking, B to C. Now, when you're going from A to B, you will see that 1, 2, 3, 4, all right, so that's 4 up here, or 4 cross, and 2 up, all right, that is what we're referring to, this 4, 2 here. And when you go from B to C, remember you always have to go in the X direction, because now you're going in this direction, so it's going to be negative, so that's -2, and then you go up 1, 2, 3, and +3, and that is what we're referring to that. So from A to C, it's simply the addition of vector AB and AC. Similarly, when you have a diagram like this, so when you go from A to C, it's like you're traveling along this road, and the arrow is indicating, and the arrow also indicating that you're going along that way. So it has to be P plus Q. Suppose sometimes you could have a diagram that was something like this, and the arrows going in this direction. Suppose this was A here, and that's B here, and C, and you're supposed to find A to C. Okay, so that is going to be, we say this is P, but now this is not Q if you are traveling along that direction. So it's going to be AB, that is what AC equals to, plus, but now if you look at BC, and when you write them in terms of P and Q, or and Q, you know, AB is P, so that's vector P, plus, but now you're going against that vector, okay? You're going in the opposite direction. So this is going to be P minus Q, and that is how this particular question will be done when you get something like this in the examination. So I'm going to bring in one more example, quick example here for you to have a look as to how I add the vectors, and it's quite straightforward. As I indicated, you are adding the x components together, that gives you that value there, okay, and then you add the y components together, the 7 plus the 2, that gives you the 9 there. So 7, 9 is the resultant. We call that the final answer. It's the redirect from A to C, from A to C. That resultant is the direct or shortcut route or journey that you take to go from one point to the other. Now, multiplications of vectors, what we refer to as a scalar quantity. Now, that scalar quantity, you know, if you compare that scalar quantity, you will realize that these two vectors will be parallel. Okay, so parallel vectors they are increasing by the same scalar quantity. Okay, so if I have here, bring in more example, what we talk about parallel vectors. So if, for example, on a diagram, if one has to show that, let's suppose this vector here, and let's call that vector A, and let's say vector A is equal to 2, 3, okay, and let's take another vector here, and we say this vector here has got, well, it should be parallel, so that drawing is a bit terrible, so let me just remove it a bit. Okay, let me just remove that one. So let me bring that in, and I say this is vector B, and let's suppose we say it is 2 times whatever this other one is. All right, so what we're going to have is 4, 6, and these two vectors here, they will be parallel vectors. Okay, so if one can actually represent them on a drawing, if one get them across, this one is a shorter version than the other one. So that's what we mean by this. So I'm going to use this concept of parallel vectors to try to answer a question that you have to find this value of b when you have got a constant here or a scalar, meaning that these are parallel vectors there because they are equal to each other. Now, when we do that particular question, is we are going to try to sort of find the one that has got one variable. You see here 6 equals to negative 3k, but here you've got b equals to 5k. So I won't use the b and the k here because it's 2. I need to use one that has got one variable. And when I do that, the 6 equals to negative 3k, I can actually calculate the value of k. Now that I have the value of k, I can actually now go back and do some sort of substitution. And that substitution is going to be in the one that is on the bottom for me to be able to find that missing one here. So I'm going to then take my value of k that I know. So this is 5 equals to 5k. The value of k is negative 2, and therefore b equals to negative 10. Right, let's talk about briefly about subtraction. Now for your level, subtraction and addition is close to the same thing. So when you have got something like this, for example, now you have got a scalar quantity here, and what I do is I multiply the 2 there with each element or component in that particular vector. So this 2 is what I multiply here, and then I am changing the minus to a plus. But you realize that now when you are multiplying two negatives together, so a negative times a negative is going to give you this positive here. And what I know also is that I know that this is a positive 3. So when I then definitely multiply a negative with a positive, I'm ending up with a negative here. Okay, so if I bring in the next step, 2 times 3 is 6, negative 4 times 2 is negative 8, and then I know that now I have 8 over negative 3, or 8 negative 3. So now I just simply add the 2x components together and the y components together, and you will realize that you're going to get 14 negative 11. Let's bring in another way that they can be asked. So you can be given vector A is equal to 2 over 3, or 2 negative 3, and B is negative 3, negative 3. And we're supposed to find twice that. So you just multiply each one in here, as I showed you here in black, with that 2. And the resultant then is 4, negative 6. Now a third of b, that means you are going to take this negative 3, multiply that by a third, or divide it by 3, it's the same thing, and when you do that, you get negative 1 and negative 1. In this particular instance, we know what our 2a is. Already it's 4, negative 6, but now we're going to add it or subtract. Now when we subtract with minus 3b, we know that b is negative 3, negative 3. And here you have to be careful a little bit with your signs, because a negative and a negative, they yield positive values. And that is why you see that I'm eventually ending up with my final answer 13, 3 there. Okay, let us take about 3 examples that we'll find in typical examination questions. So the first one here is a diagram, and they are saying that the vector AB is 2, 4, and you can actually see that that is 2 when you go to the right, and 1, 2, 3, 4 when you go upwards. Now you're supposed to write down the vectors BC, that is from B to C. So you have to be a bit careful. You are going to go 3 places to the right, but then you are going downwards, hence the negative 3 there. Now when we are doing A to C, you're going to go across here 5 units and 1 unit up, and that is how you write it down. So now they're asking you to work out a vector BC plus AC. So eventually you're just supposed to add what you already have there. And if you add 3 plus 5, you get 8. And negative 3 plus 1, you get negative 2. A second question deals with a very odd looking parallelogram, but it consists of 9 equal parallelograms inside. Now what they have done here is that they have said to you that supposed to go that route from O to A, suppose it is S and O to D is T. You're now supposed to write down in terms of using that S or that T, E to F. But now when you look at E to F, you realize that E to F here is exactly the same as that, also goes in the same direction. So it's going to be also equal to S. Then B to N, that is B all the way upwards there to N. So that is like the T here, because it's the same sort of direction from O to D, with another T here and with another T here, giving you 3 T's then. Now what they're asking is O all the way up to E. So O up to E, that is going to be S plus, because this is also T if you go in this direction. So it is just simply S plus T. So you can be asked to write them in terms of, when you're doing a little bit of algebra. Let me bring the diagram back here to bring in a few questions that we can do. Now here they are saying, suppose OA here to there is 3, 0. That is that vector there. And OD is 1, 2. That is that vector there. You are supposed to find H to K. So when you find H to K, it's going to be like 3, 0. Can you see that? It's like 1, 2, 3. So H to K is going to be the same as 3 times what we're saying O to A is 3 over that. So basically you are going to end up with 9, 0. Okay, so this is going to be 0. Be careful, because 3 times 0 is 0. Okay, so I'm going to bring it up, the solution that I have done earlier, so that you can have a look and see. The next one that you are supposed to do is O to F. So we are going to do O to F now. So when we look at O to F, if I just quickly bring up, so it's going to be from O all the way up to F. So I'm going here 1, 2. So it's going to be 2 what OA is. Okay, so it's 2 OA. And then 1 OD plus, well, OD. Okay, so whatever that OD is, 1, 2. So we are going to add them. And I'm going to show you here when I bring up the solution, so you can have an idea as to how I managed to get to this answer here of 7, 2. And it's very important that you can see that distance is represented now not by letters anymore, but what you have here is OA is represented by 3, 0 or 3 or 0. And now if you go from O to F, that is going to be 1, 2F. That is what I have here, plus 1 of OD, because OD is that distance there, which is the same here. And once you plug them in and you solve them, then you get to that answer. The other one that you need to do is from L all the way from L up to C. Now when you look at where L is with respect to C, so you're going basically 1, 2, 3, but you're going in a negative direction. Okay, you're going against what OA is. All right, so I know what OA is, but I'm going against OA, so negative. That is why I have that negative there. And then I'm going again 3 units down, so that is also going to be minus whatever OD is. All right, so we are going to find that particular one here. So let me just repeat. So when you're going here, it's positive. So when you're going from L to P, it's positive. You're going 3 places to the right. So it's similar like this distance here. All right. But here is where you are going against the grain or against the route that is there. So you're going in a negative sense. And that is why you see I have a -3 here, or -3 against whatever OD is. And when you work it out, you eventually end up with this particulars here, leaving you with 6 over, or 6, -6. So you can pause the video there, and then you can have a look and see what is it that I have done when I had to find those particulars. Okay, maybe just to re-emphasize, when you're going from L to C, that is, you're going 3 with regard to OA. Okay, because we know what OA is. And when you go in this direction, so that arrow will show you this direction, you're going against what OD is, because OD goes in that direction. So you're going against that. That is why you have a minus there. And when you combine them, you do eventually end up here. And then you just clean it up in order for you to get that final answer. Right, the last question here. So I'm going to bring in a diagram. So what they are asking us here, they are saying you're supposed to write A to B as a column vector. So be very careful here with your scale. Don't count the blocks, because 2 blocks represents 1 unit. So if you go there, it's 1, then it's 2, then it's 3 for the value of x, and then 1, 2, like that. So it's 3, 2. So do not make the mistake. When you look at your scale, always, what does 1 block represent? So 1 block here represents a half. So it's basically 1, you must carry 2 blocks like that. Then they are saying point C is such that it is BC, B to wherever C is 2, but against AB, 2AB. Okay, so actually, I think that one can find that if one work it out. 2BA, so it's not 2AB, but 2BA, all right? So when you are finding 2BA, so we go from B to A, we know that you go from B to A, you are going in a negative direction, that's -3 here, and -2 down there. So if I then work it out, I get -6, -4. So it is then possible for me to find where that particular point is. Because from now on, I just have to find where is -6 from B to C. So it's going to be 1, 2, 3, 4, 5, 6. And then a negative must go down. 1, 2, 3, 4. So I expect that particular point to be in that region. Okay, so now we are supposed to draw the line. So if I draw the line, there's where I end up, and they ask us to write down the coordinates of C, and I can see where C is, -2 first, comma, -1. So that takes care for the work that the learners who are doing vectors in 2 dimensions have to know. So I suppose you can also go through my Google channel where you will find more work on vectors. Don't forget to subscribe to my channel and share